Dear learner, welcome to today's program in your favorite channel, Hope Channel Kenya, in the segment Knowledge Quest. Our subject today is mathematics. I'll be your teacher, Mr. Omori Sylvester. And our topic today, as you can see, it's longitudes and latitudes. Longitudes and latitudes is something that probably people are aware of, and you've covered it in primary, even in high school, in the topic or in the subject geography. Now generally we say that the earth is spherical. From your geography we say that the earth is spherical and it rotates on its own axis, which is usually a north-south line. When we talk of N and S, we mean the North Pole and the South Pole. So we have the earth, and we have the axis, that is the north and south. Now in this case we are assuming that it is a straight line from the north to the south. And now, being that the earth is spherical, it is made up of circles that run from the north to the south. We call these circles the meridians, just as you can see the diagram here. Now we have the meridians, that is, they run from north to south. They pass through the South Pole and the North Pole. They show how far a place is east or west of the prime meridian. Now prime meridian, it is also called the Greenwich meridian because it passes through a place known as Greenwich in London. At that point, it is 0 degrees east or west. So let's say this is Greenwich meridian or the prime meridian. It is at 0 degrees east or west. Now any circle that moves or that runs from the north to the south, we call it a meridian. So just like you can see from this diagram here, we have a meridian that is showing 30 degrees east. There is also another one showing 30 degrees west. Another one 60 degrees east, 90 degrees east, all the way up to 180 degrees east or west. So these ones we call them meridians, or in this case mathematically we call them great circles. These ones here, they are great circles. On the same note, there are other circles that run from east to west of the Earth's surface. Now we call them latitudes. Okay, these ones also known as the longitudes. Now those which run from east to west of the Earth's surface, like for example that, remember we have 0 here, we call them latitudes. Latitudes. And they show how far a place is north or south of the equator. Now the equator is this center line that is always perpendicular to the prime meridian. So this is the equator. It is at 0 degrees north or south. And it intersects the prime meridian at a point, and at this point here, maybe we can call it O, and our O is the center of the earth. Now remember, the equator runs from east to west, and we call it, or in fact we refer the equator to a great circle. It is very different from these other latitudes because it is even bigger than the latitudes on either side of it. Now latitudes are small circles on the Earth's surface that show how far a place is north or south, while the longitudes show how far a place is east or west of the prime meridian. Now, after we have been able to know what the great circles and the latitudes are, we can now be able to locate a place on the Earth's surface. Basically, the reason why we have longitudes and latitudes is for location of places on the Earth's surface. And usually this one is done just like you do it on a Cartesian plane. Now remember a Cartesian plane. Maybe to remind you of a Cartesian plane, it always has the x and the y axis. So if you were to plot a point, you will of course start with an x coordinate and then the y coordinate. If, for example, we're having, maybe this is 2 and we have 5 here, at the point of intersection of these two here, we have it as 2, 5. The Cartesian plane, this is how we locate a point on the Cartesian plane using the x and the y coordinates. What comes first? The x coordinate and then the y coordinate. Now, borrowing that information, we are going to use that to locate a place on the Earth's surface. Now, what we do is we give it as a coordinate form, as a coordinate in a coordinate format, such that, for example, the Cartesian plane is x, y. The same thing for the longitudes and latitudes. And what comes first is the latitudes, representing the x-axis, because they are horizontal, unlike the meridians which are vertical. So basically what we do is start with the latitude and then the longitude. So location, what comes first is the latitude, then comma, the longitude. By writing that correctly, you shall have located a place on the Earth's surface. Now let me take an example before we look at something different. Let's say, for example, we have this diagram here, and because we have this as 0 degrees, 0 degrees as the equator. Let's say this meridian here is 20 degrees east, and maybe this one here is 30 degrees west. We have this latitude here to be maybe 45 degrees north, and this one here to be 35 degrees south. Remember, from the equator upwards it's north, downwards it's south. The equator always divides the Earth into two hemispheres. Hemisphere is a half of a sphere. So we can use what we have here to locate different points on this the diagram here. Maybe we have that point to be A, we have another point here to be B, maybe we have this one here to be C. What else? Yeah, let's have those first. Maybe now we start with A. I have said that to locate a place on the Earth's surface, you first write the latitude, then the longitude. Now the latitude is the one showing north and south. So look at A. Let's have another one here, maybe D. Now A is on the equator. It is 0 degrees north or south. So if it is 0 degrees north or south, so we simply write 0 degrees. You don't have to write north or south, comma. But what is the longitude now? It is 30 degrees to the west. 30 degrees to the west. And that is the location of A. Now if you write it as 30 degrees west, comma 0 degrees, and then you have it as that, this one is a wrong location, because we don't start with the longitude, but we start with the latitude and then the longitude. Let's locate B. Let's locate B. Now B is on what latitude? Remember, latitude comes first. It's on latitude 45 degrees north. So we start with 45 degrees north, comma, And what is its longitude? It is 20 degrees east of the equator, east of the meridian. So it is 20 degrees east of the prime meridian. That gives us the correct location of B. Let's try C. So C is on a latitude 35 degrees south. So we start with 35 degrees south. And then, because it is on the prime meridian, that it is 0 degrees to the east or to the west. So it's just 0 degrees as written. Now, maybe the last example, part D, they place the position of D. Latitude first, then longitude, which is 45 degrees north, 30 degrees west. Now, what does it mean to talk of 45 degrees to the north, 30 degrees to the south? What it means here is that the angle that is between the center line, the center and B, D here, the angle that is between the equator and that line that is joining the center to D, this is the angle we are talking of as 45 degrees. And if we are talking of the latitude, look at this diagram here. When you're talking, when we're talking of the longitude, there is this circle here, the small circle, the latitude, but because it has an angle that is 30 degrees from the center to the west, that is what I'm talking of as part D. This angle here that is made between the center and the line that is joining that point, that is the one that I'm talking about as 30 degrees. But now we have more examples here from this diagram here. The location of a place. Now part A, number one is A. A is at which point? A is right there, which is 60 degrees north, and then 40 degrees to the east. Then B is 60 degrees north, it is right there, and it is 100 degrees west. Well, the diagram may not be visible, but then that is the location of a place on the Earth's surface. You should be able to remember that latitude comes first and then longitude. Now, by the help of these latitudes and longitudes, we are able to calculate the distance between places on the Earth's surface. Now, this can be done in two ways, in 2 units, in kilometers and in nautical miles. Now, the relationship between the two is a constant that we can see here, that 1 nautical mile is 1.852. Now, we're moving on to calculation of distance on the Earth's surface, and it can be done in 2 ways. It can be along the small circles or along the great circles. And I have said that 1 nautical mile is 1.852 kilometers. 1.852 kilometers as the relationship between nautical miles and kilometers. Sometimes you are given a different value in the exam. So if you are given in the exam 1.852 or 1.853, be sure to work out as you have been given. Now, distance along the small circles and the great circles. Now, I have said that distance can be calculated either along the small circles or along the great circles. That is, it can be east to west or north to south, south to north, or west to east. It depends with the question. So we are going to start with the first part, and that is distance along the great circles. The distance along the great circles. Now, I'm going to take an example here before we read. Maybe we have the point D, and we have a point E here, which is 30 degrees south. This is 45 degrees north, and this is 30 degrees south. They are on the same longitude, 30 degrees west. Number one, when working out distances along the great circles, we have to ensure, or we have to confirm, that the two places are on the same longitude. For example, the point D, or the place that is at D and E, they are on the same longitude. Which longitude? 30 degrees west. Remember, this is an example. So it depends. In the exam, you'll be given, or you'll be asked as given from the diagram. This one is 30 degrees west, same to E, which is at 30 degrees west. Now, what if we had another latitude? We have the point F here, which is, say, 60 degrees north. Always know that these latitudes, the farthest they can go south is 90 degrees south, and up is 90 degrees to the north. And for the longitudes, it is 180 degrees to the west and 180 degrees to the east. Now, if we have this F here, that is at 30 degrees to the west, 60 degrees north, 30 degrees west, we can be able to get the distance between D and F. Now, always know that that will be like an arc. Now we have that. Let me join it. So we have the radius of the earth, which is this R here. Then now there is this angle that is made between D and E. Remember, D is 45 degrees north, F is 60 degrees north. Now what is the angle between them? Now to get the angle between them, you're going to subtract. So it is 60 minus 45. So what does that tell you? When finding the distance along the great circles, first find the angle between the 2 points by finding the latitude difference. We are using the latitude difference, which is 60 minus 45. That will give us the angle between the two places. After getting the angle between the two places, now we can find the length of that arc. The length of that arc to get the distance between D and F. Now, how do we get the length of an arc? Length of an arc, L, is giving us theta over 360 multiplied by 2 pi r. Theta over 360 multiplied by 2 pi r. Now, this r is the radius of the earth, which is usually given us 6370 kilometers. Unless stated otherwise, use this one. If it is not stated, then you use this one. If you're given a different value for the radius, use this 63. Use the one that you're given. But if you're not given, then use this 6370. Now we have the angle between the two places. That is 15. 60 minus 45 should be 15. So therefore, we can work out the distance between the two places as 15 degrees over 360 multiplied by 2 multiplied by 22 over 7 multiplied by 6370. After getting that, after substituting rather correctly, you use your calculator to get the answer. Of course, we have 15 times 2 times 22 times 6370 divide by 360 times 7. It gives us the answer as 1,668.33 kilometers. This is how we work it out in kilometers. We use theta over 360 multiplied by 2 pi r. And what did I say the theta is? Theta is the latitude difference. Let me state that. Theta is the latitude difference. That is how you get it. But if you were asked to get the distance in nautical miles, you're going to use a very simple formula. I can clean this one here. In nautical miles, what you will do first is get the latitude difference, which we have already obtained. Which we have as 60 minus 45, which gives us 15. After getting that, you're using the formula 60 multiplied by theta. 60 multiplied by theta. This is the formula for calculating the distance in nautical miles. So basically what you'll get is 60 multiplied by the latitude difference, which is 60 minus 45, which is 15. And when you multiply that, it gives you what? Which gives you 900 nautical miles. After getting that, you should be able to see that the first thing that you need to know is finding the latitude difference. We have an example here. That is what we've already worked. Now we have another one here that find the distance between the points 20 degrees north and 30 degrees east, that is x, and the y, which is 15 degrees south and 30 degrees east. First of all, locate those positions, their respective positions on this, on the diagram, on the globe. So I'm going to use the same diagram, or let me just clean it out. Always locate the prime meridian and the equator, 0 degrees, 0 degrees. Now we have x, that is 20 degrees north. So we have, this is 20 degrees north. Then we have 30 degrees east. And then we have x, that is 15 degrees south. And then it is 30 degrees east, of course. So this is y here. And this is x, this point. So for you to get that distance, what do? I first say that you get the latitude difference. Now look at that. This is the center here. So this one here is 15 degrees south. So this angle here is 15. And this x is 20 degrees north. So this angle here is 20. So what is the angle between x and y? Basically, you're going to add 20 and 15. Now, note this, that when the places are on opposite sides of the equator, you are going to add the latitudes, because this one is on north and this one is south. So you're going to add 20 and 35. To get the distance in nautical miles, of course, I already said that. So distance in nautical miles, so Roman 1 in nautical miles, it will be 60 multiplied by theta. And what is our theta? Our theta is 20 plus 15, which gives us 35. So when multiplying that, it gives us 2,100 nautical miles. After getting the distance in nautical miles, part B is saying that you work out in kilometers. In kilometers. Now remember, in kilometers, what we do? We already found the angle between them. That is the arc that we need to get. So it's theta over 360 times 2 pi r, which gives us 35 over 360 multiplied by 2 by 22 over 7 multiplied by 6370. What answer do we get? 35 times 2 times 22 times 6370 divided by 360 times 7 gives us 3,892.78 kilometers. Basically, that is what you're supposed to do to get the distance along the Great Circle. Now we're going to take a short break. When we come back, we'll be able to work out this distance along the small circle. Don't go away. Dear learner, welcome back. Just before we went for a short break, we were discussing the distance along a great circle. And if you can remember well, we were saying that you first of all find the latitude difference, and then you use the formulas that we already stated in getting the distance. Maybe to just remind you that to get the distance along the grid circle, first get the latitude difference. And then use the formula 60 times theta to get the distance in nautical miles, and then use the formula theta over 360 multiplied by 2 pi r to get the distance in kilometers. That is what we discussed just before we went for a short break. But now we're going to look at something different now, which is calculating the distance along a small circle. Distance along a small circle. Allow me clean this one here. Now remember we said that the distance, the small circles are those which run from east to west of the Earth's surface. If they run from east to west of the Earth's surface, then they will divide and we have the equator. We have that dividing the Earth into two hemispheres, that is 0 degrees. Then remember we have the prime meridian, which is always perpendicular to the equator. After finding that, now we know the radius of the Earth, we've already stated it as 6370. But I want us to be very careful. We want us to consider this diagram here. We have a small circle that has a radius r. It is on a latitude alpha. Now we said that latitude, this angle here, if it was 20 degrees here, it is the same 20 degrees that is at the center of the circle. So let's say this is let's just use a symbol, in this case alpha, to represent that latitude. Now we know this line here, the equator, and this latitude right there, they are parallel. That means this angle here is the same as that angle at that point. This one is at 90 degrees here. So we can pick out that triangle at that point, which is of this kind here. That radius, we are using small r to represent the radius of the small circles, because it is definitely different from the radius of the meridians, because meridians, all of them are equal, they have the same radius. But for the small circles, they have a different radius. That is why we want to see what is the expression that we'll use to get the radius of that small circle. Now remember, the radius of the Earth is from the center to that point, that is capital R right there. And then we have alpha. Now, how do we calculate the cosine of an acute angle? The cosine of an acute angle is given as adjacent over the hypotenuse. Now, in this case, cos of alpha is equal to the adjacent. The adjacent of this angle is the small r over the hypotenuse is the capital R. Now by cross multiplying, we'll have it as the small r being equal to r, the cosine of alpha. Now you have to be very careful, because the alpha that I'm talking about is the latitude of that small circle. I'm repeating this simple concept here because we have alpha being the angle at the center of that circle, that sphere, that is the latitude of that place. And then we have, or of that small circle. And then we have the small radius. The radius of the small circle is small r. Now we pick out that triangle. If we pick it out, we'll have it as r as the hypotenuse, and then r, the small r, as the radius of the small circle. Now the cosine of an acute angle is given as adjacent over hypotenuse. So that gives us cos of alpha giving us r over r, the small r over the capital R. whereby the small r is the radius of the small circle. Now, having written that, then we can know that when working out the distance along the small circle, we will not use the usual radius of the earth, but another expression for working out the radius of the small circle. Let's take an example. We have an example here that find the distance between the points A, 60 degrees north, 10 degrees west, and B, that is 35 degrees east, in nautical miles and in kilometers. Now let me use this diagram here, or rather let me just clean. Don't forget that the radius of the small circle is different from the radius of the great circle. So we have, it is always prudent to locate those points so that you can be able to work out. With practice, you will not have to draw that. Always indicate the equator and the prime meridian. And then we have A, that is 60 degrees north, and 10 degrees west. So this longitude here is 10 degrees west. And then we have B, which is 35 degrees east. Now, what is the distance between them? So we have this being A here. Let me use this one here. That is A, and then this one here is B. So if we were to draw that circle, all of it, let me try completing it. So we'll have the center at some point, and then we will have the radius right there, and then this one here. So what is the angle between them? What is the angle between them? Remember, this one is 10 degrees to the west, and the other one 35 degrees to the east. Now, because they are on opposite sides of the prime meridian, we're going to add. But what is the procedure? First, find the longitude difference between the points. Find the longitude difference between the points. So what is the longitude difference here? Because they are on the opposite sides, we add. But if they were on the same side, we will have subtracted. Because in this case they are on opposite sides, then our theta will be 35 plus 10, which gives us 45 degrees. After getting that, now we can use the formulas to calculate the distance between the 2 points. Number one, in nautical miles, it will be 60 multiplied by theta cos alpha. Should be cos alpha. Leave alone what I wrote there, it's slightly a mess. So that will be 60 multiplied by 45, the cosine of alpha, where alpha is the latitude, where the 2 points lie. So the latitude, or the cosine of 60. So what do we get here? That will be 60 multiplied by 45, the cosine of 60, which gives us 1,350 nautical miles. Now, after getting the distance in nautical miles, part B is asking in kilometers. In kilometers, Roman 2, we're going to use theta over 360, all that, so it will be theta over 360 multiplied by 2 pi r, but because the radius is different, it will be cosine of alpha, where alpha is the latitude of the 2 points. So what do we have here? That will be theta as 45 over 360 multiplied by 2 by 22 over 7 multiplied by 6370, the cosine of 60. So you should be able to substitute and get, you should be able to work out with your calculator to get the correct answer. So let's see what we get. 45 multiplied by 22 times 2 multiplied by 6370, the cosine of 60, all that you divide by 360 times 7. So that gives us 2,502.5 kilometers. 2,502 kilometers, 0.5 kilometers. You need to be very careful. When calculating the distance along the small circles, you are using the longitude difference. Longitude difference. But in great circles, we use the latitude difference. So you have to be very careful to work when working out. Now, we have an example number 2 here. We have an example number 2 here that says, find the distance between the points P, that is 36 degrees north, 125 degrees west, and Q, which is 36 degrees north, 55 degrees east in nautical miles, measured along the great circle through the North Pole. Through the North Pole. That question, you need to read it again so that you know what is being asked here. Because the question is not talking about it's not talking about the small circle. Much as the P and Q are on the same latitude, we are not required to use the formula for the small circle to work out, but the distance along a great circle. Let's first of all locate the 2 points on the Earth's surface so that we see what is required. So both of them are on a latitude that is 36 degrees north. The same needs to be done for the south when working out. So P is 125 degrees west. So let's say this one here is 125 degrees west. And then we have Q on a longitude that is 55 degrees east. Now the question is that you find the distance along a great circle for the two of them. Remember, we have our center O here. Now, what is the angle that P makes with the center? This is P here, and we have Q. What is the angle that P makes with the center? Now just join. Remember I said this 36 is the angle that is right there. And then we have Q here. This is the angle 36. So the question asks that is measured along a great circle through the North Pole. Now remember, this is the south and the north right there. So we are asked to find the distance along that arc. The distance along that arc. But we know the radius of the Earth, of course, 6370 as normal. So we are supposed to find that angle. But if we were to find the distance along the small circle, we'll get it wrong because the question is about the great circle. Now, what is the angle that is formed between the 2 points when considering a great circle? Just take a small circle of this kind here. That is the equator. Then we have P on the other side and Q. This is P here, Q. Then we have P. We know this angle here is 36, and this one is 36 degrees. But we know angles on a straight line, they add up to 180. So what is this angle between them? What is the angle between them? This one here. So what you'll do is add 36 and 36, you get 72. Subtract that from 180, that should be giving us 108. So this angle here is 108 degrees. So after getting the angle between them as 108 degrees, when considering the North Pole, that is the great circle through the North Pole, then now we can find the angle, the distance between the 2 points. Remember, we are talking about the great circle. And if it was in nautical miles, it is 60 multiplied by theta implying that we'll have it as 60 multiplied by the angle, which is 108. What answer do we get? Let's see, 60 multiplied by 108, that gives us 6,480 nautical miles. But if it is in kilometers, so we'll have it as theta over 360 times 2 pi r. Theta over 360 times 2 pi r. That gives us what? 108 over 360 multiplied by 2 by 22 over 7 multiplied by 6370. So let's see what we have. 108 multiplied by 2 by 22 multiplied by 6370. Then all that you divide by 360 times 7. That should be giving us 12,012 kilometers. 12,012 kilometers. I want to repeat something here. That we are finding the distance between 2 points that are on the same latitude, that is on the same small circle. Like for example, P is 36 degrees north, same as Q, which is 36 degrees north. But we cannot find that distance because we have been given a condition that it must be along the great circle through the North Pole. What does that mean? Somebody else can take the South Pole rather. If you look at that, what you're supposed to do first of all is get the angle between them, just as I stated. That is the angle. Now just take it out. We have 36 and 36, and then you add the 2 to get 72, then subtract from 180 and to get 108, and then you use the formulas to work out. Remember, it is a great circle, so we are not going to use cos alpha, but rather just direct. But if it was along the small circle, allow me clean this one here. That is, if the question read that find the distance between them in nautical miles along a small circle, without the condition that we had initially, along the small circle, first thing is along small circle. First thing is get the longitude difference. Now, what is the longitude difference between P and Q? If the question was talking about small circle, P and Q are on opposite sides of the prime meridian. So what you're going to do is basically add the two. 125 plus 55 should be giving you 180. So we have 180 degrees over 360 multiplied by 2 by 22 over 7 times 6370, the cosine of the latitude, which is 36. And this one should be giving us in kilometers. Let's see what we get. So we have 180 times 180 times 22 times 2 times 6370, the cosine of 36. Then you divide that by 360 multiplied by 7. The distance that you get is 16,196.52 kilometers. That is the distance along the small circle. But if you compare this one to the one that we had initially, that is when the question was talking about the North Pole, it was about 12,012. That tells you that this distance is greater than this. For the two, this one, the distance along the great circle is greater than the distance along the small circle. I think you should know that the distance, when asked to get the distance between two points, that is the shortest distance, use the distance along the great circle. Unless you didn't work it out correctly, it is good to work out both of them so that you compare. Sometimes this can be smaller than the distance along the great circle. I want to believe that working out the distance along the small circle and the great circle was very easy, because we only need to know the longitude difference and the latitude difference. Then we can be able to work out the distances between the 2 points. Otherwise, expect the two combined in a question. Like for example, if maybe a place, we have a place, maybe another place which is R, and somebody was navigating probably from Q to P, then through to R. So what you're supposed to do, first of all, consider the different formulas. First of all, take it along the small circle and then along the great circle by using the appropriate formulas. With that, we're going to end up the lesson there, but then ensure that you work out more examples so that you get to understand. That is, may God bless you.